Hey guys, and welcome to Miss Davis Virtual Classroom of Excellence. Please ignore my dog snoring in the background. I tried really hard to restart this without that, but it is what it is. So today I'm going to go over how to pick our testable question, how to start writing our claim, and our evidence. You'll notice in Teams you've been assigned an assignment. It's not due until tomorrow. Some of you longer because of extended time. It's not due till tomorrow. So we're going to start doing it, you're going to split it up. So today your goal is to have your testable question, your claim, and your evidence done, so that tomorrow all you focus on is your reasoning, because you can't jump ahead and do your reasoning first. You have to do it in order. You have to have your clear testable question, a clear answer, which is your claim, and then you have to have evidence that supports it. So I'm trying to pace you out so that you can really focus only on your reasoning tomorrow. So follow along with me. It's going to be a lot of work, but all right, so if you are in the good question category, if these are your questions, gold star to you. I only saw a few before I had to start making this PowerPoint for you guys. If yours are on the next slide, if you notice that your questions, what's going on, common errors are right here, don't be embarrassed. Nobody knows it's you. I just noticed these are questions that were very common and are very difficult to answer or aren't correct. All right, so good questions. I underlined independent and dependent variables so that you can see how you'd point them out. How does the amount of products in your house affect the amount of trash and recycling? So how does the amount of products in your house affect the amount of trash and recycling being output? I like this question. It's not perfect. It's not perfect because we're doing amounts twice. Okay, how does... Maybe you want to change this to where in your house does affect the amount of trash recycle being output. This one's a little tricky, but I like it. You can point it out, but it's not perfect. How much trash collected affect the number of recycled items? That's a good one. So I like that because trash collected, and you see it doesn't say recycled collected. Technically, recycling and trash are in the same boat. It's all waste. Trash and recycling is waste. So how much trash collected affects the number of recycling? So in that question, you would be maybe word it where your answer would be something like, the more trash collected, the more recycling you'd have. That's a good question, but you can kind of answer it without even doing the experiment. Obviously, the more trash you collect, the more is going to be recycled. Okay, do most household items have recycling or trash? So I like this one, but there's a better way to say this. How does location affect the amount of recyclable trash items found? Okay, honor students, you can do location. Standard students, I'm going to give you 3 examples of questions that you can choose from and give you the data. Some of these questions, again, like they try to be concise, but there are better ways, and I have a question in my head, so it's hard for me to break down all of these individually into how they would look long-term in an experiment. But make sure, I mean, for example, I cross this out. You don't have to make it so wordy. You can shorten it. How does trash differ from the house to outside? How much for trash and recycling are there? So I don't like the second question. Okay, by saying these are a little too vague. I know I said these are good example questions, but they're good because they're the foundations of a great question, a great testable question. Okay, how does the trash differ from household to outside? This is a great question, especially for honors. If you want to do this, I'll give you information for both studies because I really want to focus on indoor. But if you want to compare how much is outside to inside, that'd be kind of cool, but make sure you know how to reason that. Okay, how do you compare and contrast? There's more trash outside than inside. There's more inside than outside. You're going to have to look at those big numbers. You can't answer it, but there's also room for error with that question. All right, so here are some common errors that I noticed. What is the effect of sorting items on the environment? That is too broad. We didn't study a landfill. We didn't study how much trash was inside of your garbage man picking up your trash, how much was inside the truck. We only focus on ourselves, on our households. We only did a small pool. We did not do the world. We did not do Jacksonville. We didn't even do Duval County. Like, we didn't even do like an area. Remember how I had you say location? We did all throughout Jacksonville. but there's only a few of us. We didn't do every single person. Okay, we didn't sort out the garbage trucks at the end of the week. So you can't say what are the impacts on the environment. That is a long-term study. That would take years to answer. So it's a great question. I love it. But unfortunately, our data cannot answer that question. What is the effect of trash inside a house? I don't understand what that question is even asking. What is the effect of trash? So, like, are you collecting it? That's just a weird question. I can't even point out an independent, dependent variable in that one. If I change where in the house I collect trash from, will it give me more or less trash? That's a great question, but the why or why not, gotta, no. Why or why not? You're gonna answer the why or why not in your claim, okay? Trash collected from these common areas will give me, and again, the more or less, get rid of that. It needs to be more, will affect, sorry. It should be, will give, what will the effect be? Will it affect the amount of trash? So don't say more or less. So this is a great question. It's just worded not right. And you got to get rid of the I. No. How does the location I collect where trash is collected from affect the amount of trash? That's a better way to answer that question. It's a great foundation of a question, but it says I in it, automatic fail with that one, which is okay. This is a practice. Okay, what can be an effect of how much trash is recycled? Again, that's too broad. We don't know how it's going to impact us. Okay, what is the effect? The amount of recyclable items in the space range was limited. I like it, but I'm also confused by the question. I'm also confused. Space range, as in like how big your house is, or is it, again, that should be location, not, okay, so imagine, like when you say space range, I'm thinking an apartment versus a mansion. Is that what you mean by space range, or do you mean like an area? Do you mean like by, common household areas? It's just, I can't narrow down, and you can't answer this question because it's confusing. Great question, just confusing. Does changing the recycle amounts affect how long plastic will evolve around the earth? Again, too broad, and you don't put your answer, like you're answering your question in your question, and that's not the point. The question is to say, hey, here's this, and here's the answer. You got to remember the question comes first, not the answer. So this is, no. All right, so here's an example. Do not use this as an example. Do not use it. You will automatically fail because I'm giving you literally everything. I'm literally doing this with you. So if you try to do this, automatic 0. Okay, so here's what I'm going to do. Here's the question that I picked. How do the students who cannot recycle affect the amount of trash? This was a super common one, and I love it, but it's very detailed, and I think it's a little bit harder for you guys to do on your own. So this one's a tough one. This really, it seems simple, but it's actually an in-depth question. How do the students who cannot recycle, okay, that's what we're changing. We're going to compare who recycled and who didn't recycle, okay, affect the amount of trash, okay, because remember, all recycling and trash are the same thing. It's all waste. Is it reusable waste or non-reusable? That's the difference. Recycling and trash are both waste. So our independent variable are the students who can and cannot, right, okay. Dependent variable, amount of trash. That is what we measure, the amount of recycling versus the amount of trash, okay? Recycling is trash, it's waste. So I could change that to waste instead of trash. Right here, say the amount of waste, because then you're talking about trash and recycling when you say waste. Using our data, I can accurately say, this is my claim, the amount of students unable to recycle increased the amount of trash. Okay, I wrote this after I looked at my data, and I looked at it. Okay, that is accurate. The amount of students unable to recycle increased the amount of trash. Here's how I get that answer. That's how I get that claim. So my question was, how did the students, okay, that's my independent variable, affect the amount of trash? That's my dependent variable. If you notice in my claim, the amount of students, again, unable to recycle, I used increase, decrease, not almost. It is a yes or no answer, but it has to be increase, decreased, positively affected, negatively, like you have to use scientific terms, not it changed. No, I don't understand what that means. Did it go up or down? And up or down is a fifth grade answer. It's increased or decreased. Evidence. Okay, how did I get this answer? How did I get that students unable to recycle increased the amount of trash? I can only say that because I have evidence to back that up. This is not a hypothesis. It's not what this is. It's an answer. It is a yes or no answer. It increased. It affected. Yes, it affected it. But you don't say yes or no. You make a statement like it is, you are 100%, you are on it, like Sans would do. Idiota, it is the amount unable to recycle. That was a horrible impression of you, Sans, but I love you and miss you. All right, evidence. Why was that my answer? What data supported that? So in order to get that answer, I had to do some math. Oh my God, but it's really simple. If I can do the math, y'all can do it. I know that sounds crazy, but math is not my strong suit. Y'all can do percentages, and if you don't, you should, because that's how you calculate a tip when you go to a restaurant, so you're welcome. You would have to do some math and play with your data. Okay, so based on my data, I know that 22% of you could not recycle what you collected. Okay, then 22% of what recycled would have to be counted as trash. You have to take it away. Okay, and then if you notice, I asked students yes, no, or maybe. Okay, maybe you don't hide that data, which I actually made that error. You don't hide that data of maybes in your chart or graph. You can add them. You don't hide it. And I'll show you what I mean in a second. You don't add them in because they're a yes or no. We need a yes or no answer. So you don't ignore them, but you don't add them into the 22%. You don't make it 32% or 33%. You don't add the 11%. You just focus on who cannot 100%. All right. So our evidence is this. Okay. 3,249 items were in the recycling, and these were future trash items. Okay, so that's a total of 11,215 items that were going to be recycled. Okay, 22% can't. So you're going to get out a calculator and deduct 22%. Okay, it's not hard to figure out. All right, hold on, I'm going to try and get my calculator out to show you how this looks. Calculator. All right, so we got to do 22%. Whoops, sorry. Okay, so we've got 11,215 times 0.22. Okay, you move that decimal point over. Wow, that's how many items can't be recycled. Okay, so we've got, I got rid of the decimal, so we've got 2,467 items that are now have to be counted as trash, and add them to non-recyclable amount to trash. Okay, so then you add this. Okay, this is the math part. So now I add this to the amount of trash, which is 7,485. Wow, that's how many items are now trash. Okay, so not only do you have to add this amount to trash, you have to reduce it. You have to add this much to here, and then you have to subtract that much from here. Okay, so now there's over 9,000, almost 10,000 items are trash, and now recycling has lowered from 11,000 to 8,000. Okay, and let's see how this looks on your graph in your table. Okay, so if you notice on my data table, I didn't even put in here maybes. You could, if you wanted to show in another column right here, the amount of data of students who said yes, no, or maybe, you could do that. But I just didn't use it. If I was turning in my field notes, I would, but I've got that information. You don't need to. I just want to clarify that. So I didn't use it in here because I just focused on how much I knew 100% wasn't recycled. Okay, so here's what I did. Here's my chart. Okay, here's my chart. Items. This is really easy to make. I can show you how I made it if you need me to. It's really easy to do. Really, like, it's not hard, I promise you guys. So to make one of these tables, all you got to do in and it works the same thing in Word, but if it's easier for you, it's easier for me to actually make this and copy and paste it into Word. I make it in PowerPoint and post it there. I think it's easier. You don't have to listen to me. It's really easy. All you do is you go to Insert and you say Charts, or you add a table. And then you just pick how many you think you need, and if you don't have enough, you can add them. Really easy. Like, let's say I needed to add another one. Where is it? There's a way to do it. I'm trying to think. Click this one. Hold on. Let me pause this for a hot second. Okay, I got it. The total amount, so second sentence is the total amount of trash increased from this to this. Okay? Shows an increase. So here's my evidence. And the third thing I could do is if I want to do the percentage of change. So that would be, that's not a number that you show in your graph, so you're fiddling a little bit. But if you wanted to say that amount, I mean, I think it's 22% no matter what. But you notice how I didn't mention recycling? You can. Recycling decreased. Oops. Decreased. Oh, I can't spell. From blank to blank. You can add that. Totally. You can totally add that. Because that's in a report. It changed. It fluctuates. Okay? The amount changes a lot. All right? So that's how you write your reference. Right there. You only talk about your numbers. Reasoning is when you get into the why. Reasoning is the why. Okay? And we're going to get in that tomorrow. I'm literally just going to add it onto this PowerPoint and go over the reasoning for this experiment. Now, honors, you have to go and start from scratch. You are creating your testable question. You're using what I gave you as examples. This is going to be attached to your assignment, so you can go in and look at this, kind of see what I'm going to change this to good examples, to example questions, may or may not be great. May or may not be great. I'm going to say correct. That's what I'm going to say. They are all great. They're just not fully correct. Okay, so again, I should not see anyone do this assignment like this way. I'm using this as an example. So it's just a common question, like how somebody asked me, how much would it impact? So once you get your question, and at any point, if you're trying to force the data to match your claim, your question is wrong. So the question is honestly the hardest part of this entire thing, because if your question is wrong, your answer is wrong, then your evidence is wrong, then your reasoning is wrong. Like, it just becomes a chain of wrong. So don't rush deciding what your answer is. And if you start creating your question and your answer doesn't match your question and you can't find a correct answer, you cannot make a claim, then you need to start with a whole new question. You might have to do some trial and error. Okay, so my honor students, take your time. Really look at this data, formulate a question. If you made a question yesterday that wasn't great, redo it, because your question will mess your entire project up. And this is 20 points. Honors, I'm almost considering making it 30 points because you have to make your graph and you have to do literally what I just did. Honors, I literally did almost your entire assignment, how you would have to do it. Standard, you don't need to do all this as much. I mean, you have to do this part, but you don't, the claim is already kind of, no. The only thing that's done for you, honestly, is the testable question, and that they don't have to do a full graph. But the graph does help you, okay? Standard just has to do a data table. They have to make this. Honors, you have to make this. Okay, remember you're in a high school class. I was explaining to a student earlier today, I know this video is long. Okay, why am I doing this? Like, why do I need to know how to do this? You actually have done a CER in English. English, you do this, but you have textual evidence. Have you ever heard Ms. Flores or Mr. Kane or Ms. Lipscomb, any of them say textual evidence? Pull out evidence that supports what you're saying. That's evidence in a CER. Claim is your thesis statement. Textual evidence is evidence, and your reasoning is when you explain that thesis statement. Wow, you have been doing this. The difference is, in English, you have a paragraph, multiple paragraphs, a chapter that you have to break down. In science, you are using numbers to break down and create words that back up those numbers. That's the difference. In English, it's all words, maybe with some numbers smooshed in, but it's written. You have to read it. In science, you have to read what the numbers are telling you. Okay, and that's math. Science really incorporates math and English. Science is 3 subjects in one. That's why science is hard for people, because if you're great in English, you'll be all right in science. If you're great at math, you'll be all right in science. If you're good at math and English, you are a science genius, which isn't even me. I'm terrible at math. I try to keep it easy. I like to do percentages. Great. I'm great with that. I'm great with statistics. That's a different type of math. So I'm good with that. Everything else, not so much. So just keep in the back of your mind. You have already done this, but you're doing it through the scientific way. If any of you, I know some of you, I had to do a recommendation for doing the medical program at Mandarin and other schools. Doctors literally write a CER every time you go to them. So every time you go to a doctor, they're going to try to figure out what's wrong with you. That's our testable question. What is wrong with this person? Okay, why are they here? Why are they sick? They're going to ask you that. They're going to get a hypothesis. Well, doctor, I think I have high blood pressure. I get dizzy when I stand up. Okay, the doctor's going to say, well, let's test it. Let's check your blood pressure. Cool. He's going to check your blood pressure. He's going to compare it to other times when you have blood pressure. He might have you watch your manager blood pressure for a month and then come back and look at it overall. Yep, every day you have high blood pressure. We're going to figure this out, because if you have high blood pressure, you can have stroke and other issues. Okay, so your doctor is then going to fill out a report. He is going to make a claim. This person has high blood pressure. The evidence is, over the course of a month, their high blood pressure never went down. It only increased, and they're going to compare that with evidence. Okay, 25% of the time it was low. That means 85% of the, or 75% of the time it was high. Okay, so he's going to put that in there. 75% of the time that they recorded it, they had high blood pressure. Evidence. Reasoning. Reasoning may be lack of exercise. They didn't go out very much in their data. Reason may be a thyroid issue. More data to be collected. Okay? Every time you go to the doctor, they write a CER. Okay? So this may seem like a waste of your time, but you literally use this every day. Somebody uses this every day. Our frontline heroes are out there using this stuff every day. So show some respect for those people who are out there working hard. Maybe they're your parents. If your mom is a nurse or your parent is working in healthcare, they are doing this. They are writing CERs every single day when they walk into a room with a patient. Okay, so show a little respect for what some people do and what's keeping us safe, all right? So take your time. Do not rush through this. If I see that students are struggling, I'm happy to extend the due date. But for right now, focus on one thing at a time. And today that is getting your testable question, getting your claim, and starting your evidence. Tomorrow is all about evidence and reasoning and turning it in. All right. Best of luck, my friends. Have a great rest of your day. Bye.